Okay, so we've seen how they will bind to one another. Okay, binding site saturation. Let's see if we can get this one to work. Alright, let me see if I can click on it and try it in your version of it. On the downloadable version, it's very, very good. Classes of receptors. Membrane-bound receptors. They span the entire plasma membrane, and they bind to water-soluble or large weight hormones. Intracellular receptors are found in the cell cytoplasm or the nucleus, and they will bind. Okay, they will bind to lipid-soluble hormones. Alright, so here's another video that my presentation software is not going to allow me to use, but make sure you check this out. It's very nice, where the aldosterone comes into the cell and then fuses with the DNA and causes production. And basically, just like it shows here in the chart, how those steroids or the hormones will break down and go across from one area to the other, and how things will change. Membrane-bound receptors. Okay, hormones are categorized into a couple different types. Okay, including the membrane-bound receptors. Okay, the membrane-bound receptors is what we're going to look at first. The membrane-bound receptors are definitely going to alter the activity of G proteins, and G proteins are typically found on the plasma membrane. Okay. Good enough shorthand there, hopefully. Okay. And on the plasma membrane, these G proteins move, and when they do, they open or close ion channels. Okay, and this activates existing enzymes underneath the membrane that will start a cascade and produces, in the end, a cellular response. Okay, let's talk about the other group of membrane-bound receptors. Okay, here receptors alter the activity of intracellular enzymes, so those that are inside cell. Okay. Those that are found inside the cell are activated in this case, and then it activates existing enzymes inside the cell, producing the cellular response. Okay, hormones that work on intracellular receptors. Okay, quite a bit different. These intracellular receptors will activate genes. Okay, so if it activates genes, it's going to the DNA, and typically the DNA is found where? Yeah, that's right, in the nucleus. So these types of hormones follow a different rule book altogether. They move all the way inside of the cell, all the way to the nucleus. Okay, and this typically causes the synthesis of a new protein or enzyme. Okay, it must go through transcription and translation in order to produce those. The central dogma: DNA to RNA to protein. Okay. Alright, so there's several classes of receptors we'll look at here. Many of the membrane-bound receptors produce responses through the action of G proteins. Okay, these G proteins consist of three subunits: the alpha, beta, and gamma subunit. Okay, the inactive state, or the GDP, is bound to an alpha subunit. Okay. G protein bound to an alpha subunit. Okay, and the active site is also bound to an alpha subunit. And some of the hormones that activate G proteins include the luteinizing hormone, FSH, follicle stimulating hormone. Okay, thyroid stimulating hormone, also known as TSH. Okay, adrenocorticotropic hormones, oxytocin, and antidiuretic hormone, ADH. Okay, calcitonin, parathyroid hormone, glucagon, and epinephrine, not norepinephrine. Discard. I need to figure out how to make that not come up every time. Okay, so here we see the water-soluble protein coming in, and it binds to the receptor on the plasma membrane. Okay, that plasma membrane binds it, and then it causes a change in the G protein. Okay, the alpha subunit will then move the GDP, or cause the GDP to be activated from GDP to GTP. Okay, and then GDP replaces GDP on a subunit, and that G protein separates from receptors, okay, and then moves on down. So you see how we have the gap forming here, okay, moving that direction. Okay, the gap there, the G protein or the gap protein is moved over. Don't always call it gap, but in this case it will work. Okay. Alright, water-soluble hormone. After it's been activated, it will separate from its receptor. Okay, and once it's no longer there, activation has occurred, and you will see changes after that. Nice little video on this slide. I want you to make sure you watch that and can understand that process. Okay, G proteins and ion channels. Okay, G proteins and ion channels. What's going on here? Well, first, the alpha subunit, when it's bound to GTP, combines with the calcium channel. And when it combines with the calcium channel, it causes that calcium channel to open up. So if the calcium channel is opened up, it's going to allow calcium to either enter or exit the cell. Okay. So calcium that can then go and bind calmodulin. Okay. And it produces a cell response to the hormone that was initially initiated. Okay. Another video here, I want you to make sure you watch this, is the calmodulin activation through the calcium channel through the G protein process. Okay, G proteins and enzymes. The water-soluble hormone is bound to its receptor and the G protein is activated. Looking at it in figure 15.7, and here we're looking at figure 15.8. Okay, the activated alpha subunit, when it's bound to GTP, binds and activates an adenylate cyclase enzyme to convert ATP into cyclic AMP. Okay, and then it produces two inorganic phosphate groups. So two phosphate groups are kicked off. The cyclic AMP activates protein kinase enzymes, which then phosphorylate specific enzymes, activating them. And the phosphodiesterase enzymes inactivate cyclic AMP, converting cyclic AMP into simply AMP, adenosine monophosphate. Okay, go through this process right here. Signal transduction by extracellular receptors. Very, very, very informative there. Classes of receptors. A hormone binding to a membrane-bound phosphoreceptor can directly activate intracellular enzymes. Okay, and those enzymes can in turn either synthesize intracellular mediators such as cyclic GMP, add phosphates to the intracellular enzymes, and alter their activity.